Imagine staring at the sun through the cold eye of a satellite, unchanging, eternal, calm. For weeks its face has slept, blank and golden like a god in meditation. Then, without warning, light erupts. Not once, but 3 times. Successive flares blooming like scars across the surface of a star that should have been silent. The year is 2025, mid-October. The Solar and Heliospheric Observatory, SOHO, a sentinel that has watched our star for 3 decades, streams its daily images from 1 million miles away. Among them, buried in routine data, one amateur astronomer notices something impossible. Tiago, known online as Dobsonian Power, sits before his screen in São Paulo. The feed shows the sun's halo, filmed by the Lascaux coronagraph. 3 shadows glide across the field of view, small, dark, symmetrical. They move not with the wandering chaos of cosmic dust, but with precision. Each crosses the frame as if obeying choreography, and moments later, the sun detonates. 3 crossings. 3 eruptions. In astronomy, coincidence is a dangerous comfort. A flare can ignite from magnetic stress, yes, but 3 aligned bursts perfectly timed to the passage of 3 objects belong to another vocabulary. To randomness, the odds are microscopic. To intention, the odds feel almost inevitable. Tiago posts his discovery online. At first, it reads like another cosmic curiosity, the sort of glitch that fills sky-watching forums. 3 companions following 3-eye Atlas, he writes, each one triggering the sun. Yet within hours, the thread explodes. Atlas, the interstellar comet detected the previous winter, had already rewritten textbooks. Its path, a hyperbolic arc cutting through the inner solar system, proved it came from beyond our star's gravitational reach. But now, behind the sun, it seems no longer alone. Across the world, other watchers begin to check their instruments. A user called Night Monkey in Chile uploads frames from an all-sky survey. Tobazil, an observer in Poland, confirms rapid moving points near Gemini, perfectly matching the time window Tiago recorded. Multiple vantage points, same pattern. For any scientist, replication is the border between rumor and reality. And replication, it seems, is exactly what the cosmos has delivered. Yet the agencies that see everything, NASA, ESA, the solar physics divisions that normally flood social media with every minor flare, say nothing. No briefing, no correction, no denial. Just absence. Silence, Dylan, has its own frequency. When the world's brightest institutions say nothing about an event that violates orbital mechanics, that silence becomes a kind of signal, an inverse acknowledgement that something sits beyond the reach of official explanation. In the days that follow, independent astronomers dig into the data. The flares correspond to a triple coronal mass ejection, each wave releasing billions of tons of plasma into space. Their symmetry is uncanny. The sun, long dormant, behaves like a sensor tripped 3 times by the same unseen hand. Skeptics call it coincidence. Believers whisper coordination. The statistical gulf between the two is measured not in percentages but in impossibilities. If you shuffled a deck of cards and drew the ace of spades 500 times in a row, you would still be nearer chance than these eruptions. Tiago's footage migrates to YouTube. It's dissected frame by frame, compressed, enhanced, slowed to fractions of a second. The objects show no tail, no outgassing, nothing cometary. They are dark against the blinding corona, aligned almost equidistantly, moving as if under guidance. It's tempting to romanticize such events, to leap straight to craft and intelligence, but history teaches restraint. In the 1940s, when radar first captured Foo Fighters above war-torn skies, official channels buried the data under layers of classification. In the 1970s, NASA's Pioneer spacecraft detected signals misinterpreted as alien beacons before engineers found mundane explanations in thermal recoil. Skepticism protects truth, but it also blinds us when used as a shield against discomfort. Physicist Sabine Hossenfelder once warned that dismissing artificial possibilities outright is not skepticism but dogma. Our greatest error, she wrote, will not be in believing too much, but in refusing to look. Perhaps that is what is happening again. Meanwhile, Atlas continues its voyage, a faint emerald spark beyond Mercury's orbit, trailing dust from a world older than our solar system itself. It travels at 58 kilometers per second, untouched by the gravity wells that bind everything else. Some astronomers call it a wanderer, others a messenger. If Tiago's companions are truly moving with it, they represent something more organized than nature prefers. Formation flight is rare in the cosmos. Objects obey gravity, not geometry. Yet these three maintain pattern and pace, like satellites keeping watch over their parent body. Could they be fragments, pieces torn loose by tidal forces? Possibly, but fragments drift. They scatter, they fade. These do not. In the absence of data, imagination rushes in. On forums and podcasts, voices propose theories: automated probes, solar observers, extraterrestrial drones harvesting data from our star. It sounds wild, yet behind the noise hides a sober question. What would non-human intelligence actually look like if it chose to watch us? Would it announce itself, or would it do exactly this? Remain hidden behind the brightest object in our sky, shielded by radiation, invisible to casual eyes. To watch the sun is to watch a veil of fire. Whatever lingers behind it exists beyond easy scrutiny. In professional science, patterns like this provoke unease. They test not only equations but egos. Admitting anomaly means admitting uncertainty, and uncertainty erodes authority. Institutions built on predictive models recoil from chaos. It's safer to wait, to withhold comment, to let the event fade from public memory. But data does not forget. The SOHO archives preserve every frame, every photon time-stamped and stored. The correlation remains there: 3 shadows, 3 flares, a cosmic choreography no press release has yet named. We, the onlookers, are left with the simplest and oldest question in science: what are we actually seeing? If it is coincidence, then nature has written a poem so perfect we mistake it for purpose. If it is intention, then something beyond human origin has just touched our star. Either way, the universe has spoken in light and silence. As the solar plasma unfurls into space, a pale ripple of charged particles sweeps past our planet. Satellites blink, auroras flare, compasses tremble. The storm carries no message, no pattern, only energy. Yet some wonder if energy can be message enough. Because sometimes, Dylan, the cosmos does not whisper through words or radio signals. Sometimes it speaks through timing, the alignment of events too exact to ignore. And when the sun itself wakes to answer, even the most skeptical observer must ask, who knocked first? Patterns are the language of the universe. They whisper through everything we see. The spiral of a galaxy, the symmetry of a snowflake, the pulse of a neuron firing in the dark. When a pattern emerges where none should exist, scientists take notice. When it repeats 3 times in perfect sequence, they begin to wonder if the universe is trying to speak. The triple eruption recorded on October 15th was not supposed to happen. The sun had entered a period of magnetic calm, a lull between cycles when even minor flares become rare. Solar physicists track such phases carefully, for they influence our satellites, our power grids, even the safety of astronauts. Yet, in this quiet stretch, the star woke violently, precisely when the 3 unidentified objects swept behind it. Statistically, the odds of that correlation are infinitesimal. Thiago's data, confirmed by time-stamped records from the SOHO LASCO C2 instrument, showed the sequence lasting less than an hour. Each dark mass entered from the same trajectory, equidistant from the last, and each passage was followed by an energetic outburst measured at over 10-15 joules. You could call that luck, or you could call it design, but geometry doesn't believe in luck. In science, patterns demand models, and models demand humility. Yet humility is difficult when faced with something that doesn't fit. Within days of Thiago's upload, astrophysicists and engineers attempted to model the phenomenon. Some proposed that micrometeoroid clusters had fallen inward together, guided by similar gravitational vectors. Others argued for instrument artifacts, random pixel noise misread as solid shapes. But neither explanation survived numerical scrutiny. Micrometeoroids scatter chaotically, not in formation. And LASCO's image pipeline has been calibrated for decades. False positives appear as streaks or static, not as three symmetrical silhouettes moving in tandem. As the online debate expanded, data specialists began comparing Thiago's frames to past anomalies. They found nothing remotely similar. For 30 years, SOHO has filmed the sun day and night, amassing more than 25 million images. In that vast archive, no other event mirrors the geometry of October 15th. So the conversation shifted from what are they to why now? If these objects were merely debris following 3I Atlas, why would their appearance coincide with the comet's near-solar approach? And why would the sun respond as if awakened by their crossing? Here history casts a long shadow. In 2020, when Comet 2I Borisov, another interstellar visitor, passed through the solar system, it showed no such correlation, no solar flares, no electromagnetic disturbances. Yet, 3I Atlas seems to carry turbulence with it, as though the space around it behaves differently, distorted by its passage. Thiago nicknamed the objects companions, dark siblings he called them, and soon the term stuck. The Atlas companions entered online lexicons, sparking both fascination and ridicule. Scientists dislike romance in their data, but the human brain, wired for pattern recognition, resists indifference. We survived evolution by detecting the glint of predator eyes in the dark. That same instinct now stares at a trio of black shapes against the sun and feels the primitive weight of meaning. Maybe we are overreacting, or maybe we are remembering. By the third week of October, correlations multiplied. Amateur sky surveys in Argentina and Spain picked up short-duration photometric spikes aligned with the sun's coordinates, faint signatures that coincided with each flare. These were not visual illusions. They were registered in raw brightness curves, instruments confirming what human eyes could only intuit. A physicist named Riley Chambers, writing for Astrophysical Journal Letters, offered a cautious interpretation. If the data hold, he wrote, we may be witnessing an unknown category of near-solar transient, either mechanical debris or charged aggregates interacting with magnetic fields. In plain language, something was there, something with measurable presence. Still, no official agency commented. NASA's Solar Dynamics Observatory, ESA's Solar Orbiter, JAXA's Hinoda, all remained publicly silent. The absence became deafening. The few insiders who spoke anonymously to journalists described an atmosphere of unease. There's nothing we can confirm, one researcher said, but no one wants to be the first to say the word artificial, because once that word escapes, it changes everything. The geometry of coincidence became the geometry of avoidance. Scientists debated probabilities while ignoring the emotional truth. Data that challenge our worldview often die not by contradiction but by neglect. To call something impossible is easy. To admit that our understanding might be incomplete, that's harder. The physics of the event resist dismissal. Solar flares are triggered by magnetic reconnection, a process where tangled field lines snap and realign, releasing pent-up energy. But reconnection requires local stress, the kind that takes days, sometimes weeks to build. Nothing in solar dynamics suggests that a passing object could provoke it 3 times in minutes, unless perhaps the object carried charge, a foreign magnetic field. Even a small one could disturb the delicate equilibrium of the sun's corona. Theoretical physicist Dr. Eiji Nakamura once proposed that charged bodies traversing near solar space could act as catalytic seeds for localized reconnection. Until now, it was a mathematical curiosity, a scenario unlikely to occur. But what if it already has? If the companions of 3I Atlas are charged, metallic, conductive, engineered, they could, in theory, trigger the very flares we observed. The sun, then, would not simply be reacting, it would be responding. The idea feels audacious, but audacity has always been the pulse of discovery. Patterns don't lie, but they can mislead. For every truth the cosmos reveals, it hides another inside coincidence, daring us to tell them apart. So the investigators turned to the data again. They stripped the images, aligned the timestamps, corrected for parallax, compared the trajectory vectors. Every computation led back to the same geometric perfection. Spacing so uniform that one scientist joked, "It's as if someone drew it with a ruler." Yet nature, for all her chaos, occasionally loves symmetry. The rings of Saturn, the lattice of snowflakes, the twin lobes of Comet 67P. So maybe this, too, is natural and a trick of perspective, a cosmic illusion born of timing and alignment. But the human mind keeps circling back to intent. If you could stand near the sun and watch it firsthand, if you could see those 3 small silhouettes gliding past its inferno, what would you think? Would you call them random? Or would you feel in your bones that something larger is unfolding, something scripted in a language older than physics itself? Tiago's voiceover in his uploaded video ends quietly. "When I first saw it, I thought my data was corrupted, but then the sun exploded. And I knew, whatever these are, they know exactly where they're going." He never claimed aliens. He never claimed technology. He simply presented the geometry and the undeniable order in the chaos. That order is still there, printed in light, archived forever in the servers of SOHO. 3 paths, 3 flares. 3 questions. Are we witnessing nature's rarest coincidence, or the faint signature of intelligence hiding in plain sight behind the brightest veil in our sky? The truth lies somewhere in the geometry, and geometry, unlike words, does not lie. Light is an honest messenger. It cannot lie about where it has been. When a beam travels through dust, ice, or metal, it carries a subtle fingerprint, a vibration, a tilt, a whisper of orientation. To physicists, that whisper is called polarization, and for nearly every comet ever studied, that whisper follows predictable rules. But 3I Atlas refuses to follow them. In January 2025, a research group led by Dr. Nathan Gray at the Mauna Kea Observatory released a paper analyzing the comet's reflected light. Using high-precision polarimetric filters, they measured how the light from the sun scattered off its surface. Every known comet, from Halley to Borisov, clusters between 0 and +2% polarization. That's the normal signature of dust grains mixed with ice. iAtlas, however, produced a reading of 2.7%. Negative polarization, an inversion like a mirror that returns the opposite of what's expected. To understand how strange that is, imagine a violin string that hums backward, a note bending against itself. Polarization behaves the same way. It should oscillate in all directions perpendicular to its path, yet here the oscillation flips, as if the material is twisting light rather than scattering it. For weeks the data sat in confusion. The team reran calibrations, verified against calibration stars, checked atmospheric corrections. Nothing changed. The paradox held. In theory, negative polarization. This strong would mean that 3I Atlas's surface is composed of large, dense, and possibly metallic grains. Normal comet dust or fragile silicates, porous ice, cannot do that. Something about the surface of this object manipulates light as if it were passing through engineered nanostructures, not cosmic dust. The paper's conclusion was cautious, almost frightened. The observed polarization curve deviates significantly from all known cometary baselines. Current scattering models fail to reproduce the inversion amplitude. Translated, we don't know what this thing is made of. Avi Loeb, the Harvard astrophysicist unafraid of unpopular questions, read the study and quietly assign probabilities. Natural composition 40%, he wrote in his notes. Engineered or exotic material 60. He didn't mean spacecraft plating or alien hulls. He meant that the optical behavior suggests a structured surface, one that interacts with light coherently, as if assembled, not randomly aggregated. In the control rooms of observatories, skepticism turned to unease. When data violate expectation, scientists first blame their instruments. But when every telescope says the same thing, blame grows heavy. By February, the European Southern Observatory's VLT polarimeter confirmed the same inversion. So did amateur measurements from Spain's Calar Alto facility. Even SOHO's coronagraph data, crude but reliable, showed polarization, drift inconsistent with ice dust. The sun was shining the same light on everything, yet only this object bent it backward. To visualize what polarization reveals, think of sunlight as a field of ripples on water. When those ripples hit a surface, they reflect in preferred directions. Smooth ice scatters them evenly. Metallic or ordered textures align them. 3I Atlas aligns them the wrong way. Something on or within it absorbs the electric field and re-emits it with phase reversal, a behavior typical of dielectric composites or metamaterials. Not rock and ice, if that phrase sounds like science fiction. Consider this: humanity itself has begun manufacturing metamaterials capable of bending light in similar ways. They form the basis of prototype cloaking devices, thin lattices engineered to twist electromagnetic waves around them. Could nature have built something like that first? Possibly. But it would require conditions we've never seen: extreme heat gradients, pressure cycles, or chemical reactions in exotic molecular clouds, or something built it deliberately. The story of polarization is not just optical, it's philosophical. Light defines how we see the universe, and polarization defines how the universe hides its texture. When 3I Atlas twists that signature, it's as if reality itself is wearing camouflage. Dr. Gray's team nicknamed the curve the impossible fingerprint. Even now, their datasets sit on public archives, clean, open, undeniable, and yet few major institutions reference them. Why? Because anomalies this severe demand new physics or new humility. Both are uncomfortable. As more observations poured in, another pattern surfaced. When the comet rotated, polarization values oscillated rhythmically, as if certain regions on its surface were active, others dormant. That modulation implies geometry. structured facets reflecting differently with each spin. Picture a diamond rotating in sunlight. Each face flashes in sequence. Now replace that diamond with an interstellar traveler, each turn broadcasting a different polarization angle into the void. If you were trying to encode information in light, not as radio pulses, but as polarization states, this is how you might do it. No one claims that's what's happening, but the resemblance is haunting. The paradox ignited debates reminiscent of the early 20th century crisis in physics, when blackbody radiation refused to obey classical laws and forced Planck to invent quantum theory. Some researchers quietly suggest that 3I Atlas might represent a similar inflection point, an object whose optical behavior demands a new branch of materials science. Others remain pragmatic. Maybe it's a dust-poor, rock-rich nucleus with dense silicate plates that polarize differently. Maybe the surface has been vitrified by cosmic rays into glass-like armor. These are rational guesses. But rational guesses still orbit the same question. Why now? Why would an interstellar comet carry a composition so unlike anything we've seen in billions of local years? If it were a relic from the dawn of another star system, or from the galaxy's outer halo, its material signature could preserve chemistry from an era before our sun existed. In that case, the inversion is not technology. It's memory, a fossil record written in light. That idea comforts the cautious. It allows wonder without admitting intent. Yet, as the weeks passed, the light curves grew sharper. The negative polarization deepened as the object neared the inner solar system, suggesting that whatever caused it was amplifying, not fading. Normally, comets brighten, but their polarization stabilizes. Here, both changed. It was as though 3I Atlas was shedding its disguise. Spectrographs later showed minute oscillations in the phase curve, synchronized with the sun's rotation. An impossible coupling across millions of kilometers. Light seemed to dance in answer to solar rhythm. Coincidence? Maybe. But the cosmos rarely wastes symmetry. By late February, a new question emerged in research forums. If this is what we can see, what can't we? Polarization is only half the story. To understand what an object truly is, one must dissect its spectrum, the fingerprint of its chemistry. Light can tell us not just how something shines, but what it's made of: iron, nickel, cyanide, or something stranger still. If 3I Atlas bends polarization beyond physics, perhaps its chemistry breaks expectation too. And indeed, when the Keck Observatory in Japan pointed its mirrors toward the object, it saw something that defied chemical logic. The iron lines were missing. The nickel lines were strong. The ratios screamed artifice. But that, Dylan, belongs to the next chapter. Every object in the universe speaks its chemical name through light. When photons pass through matter, they emerge scarred, streaked with lines that tell us what they've touched. Iron leaves one kind of scar, nickel leaves another. Carbon and cyanide carve their own spectral tattoos into the darkness. This is the vocabulary of the cosmos. The spectrum, a silent alphabet that astronomers have been reading for centuries. But when the Keck Observatory in Japan turned its telescopes toward 3I Atlas, that alphabet broke. It began with an expectation. Every comet we've studied, from dusty wanderers in the Kuiper Belt to icy relics from the Oort cloud, carries a familiar ratio of metals. Iron and nickel appear together, locked in cosmic partnership, forged in the same supernovae. Where you find one, you find the other, their spectral lines intertwined like threads of the same story. In 3I Atlas, that story was rewritten. The nickel lines blazed like a beacon, bright and clean. The iron lines were faint, nearly absent, erased. The nickel-to-iron ratio wasn't just abnormal, it was orders of magnitude beyond anything seen before. To the scientists at Keck, it was like discovering gold veins in a stone that should have been sand. Even more perplexing, the comet's cyanide emissions, usually a telltale signature of volatile ices, were strangely suppressed. Normally, when comets warm near the sun, their surfaces vent cyanide gas, glowing emerald under ultraviolet light. But in 3I Atlas, the cyanide lines were weak. Nickel was strong. Iron was missing. The numbers defied natural chemistry. For weeks, the data circulated quietly between observatories. Most dismissed it as calibration error. But rechecks confirmed the same result, a metallic composition that nature, left alone, does not produce. One of the Kekkei spectroscopists, Dr. Aoi Nishimura, phrased it carefully in her field log. The Nephi ratio in 3I Atlas is consistent with refined or fractionated material, potentially industrial by terrestrial standards. Industrial.a, dangerous word in academic. Astronomy, because it implies process, intention, design. To understand why the ratio is so damning, you have to know how stars bill metals. Inside stellar cores, fusion forges elements through equilibrium. Iron and nickel, born together, siblings of thermonuclear birth. When a star dies, it scatters them evenly into space. Over billions of years, dust clouds condense from that mixture. Planets form. Comets crystallize. The universe, in short, doesn't play favorites. You can't get a nickel-rich, iron-poor body without doing something to it. There are only two known ways to separate nickel from iron. 1. Through extreme, selective geological processing, conditions too stable and rare for a comet. 2. Through industrial refinement. On Earth, humans use a chemical compound called nickel carbonyl to extract pure nickel from ore. It forms when nickel interacts with carbon monoxide under controlled temperatures and pressures. An unnatural marriage, dangerous and efficient. It is, quite literally, manufactured metal vapor. And 3I Atlas, drifting through the void, carries its spectral ghost. When Avi Loeb saw the data, he did not flinch. He'd been here before, when Oumuamua, the first interstellar object, flashed through our solar system in 2017 and refused to behave like a comet. It accelerated without outgassing, spun like a thin disk, and then vanished. Loeb had argued that its reflectivity, its albedo, hinted at something engineered. The scientific world laughed. Now 8 years later, another wanderer had arrived, and it glowed with industrial fingerprints. Loeb's private notes, later leaked from a lecture draft, read simply, "If the chemical composition is accurate, 3I Atlas cannot be explained by natural astrophysical processes alone. The probability of artificial separation exceeds 0.4, 40%, enough to unsettle every boardroom at NASA." Naturally, counter-arguments followed. Some claimed that extreme heating during interstellar travel could vaporize iron preferentially, leaving nickel behind. Others invoked non-equilibrium condensation, rare thermal conditions that might mimic industrial refining on cosmic scales. But the math didn't hold. To achieve the observed ratio, you'd need temperatures oscillating between 900 and 1400 Kelvin with repeated phase transitions. Impossible in the cold emptiness between stars. And if it were merely a relic of ancient stellar chemistry, we would have seen its like before. But there is nothing like it in the databases, so quietly, a few researchers began to whisper another hypothesis. Maybe this isn't a comet at all, maybe it's hardware. The phrase hardware doesn't necessarily mean a ship or probe in the cinematic sense. In scientific speculation, it can mean self-sustaining material systems, autonomous devices, maybe dormant, maybe operating, designed to endure eons. If a civilization wished to send sensors across interstellar distances, they wouldn't choose fragile radio transmissions. They'd choose physical couriers, resilient bodies disguised as natural debris, indistinguishable from cosmic dust until the right light exposed their secret. SOHO Atlas fits that disguise almost too well. It appears cometary until spectroscopy reveals its metallic core, its engineered fingerprint hidden beneath layers of dust. It is as if it wants to be mistaken for nature. Still, the rational mind resists. It's far easier to believe in chemistry than intent, so Loeb and others proposed a middle path, a hybrid model. In this view, 3I Atlas could be an object that began as natural rock and ice, but was later altered by unknown processes. Maybe radiation sculpted it, maybe cosmic collisions forged it into something unique, or perhaps it encountered a technological civilization long ago and was changed, altered, repurposed, sent onward. Whatever the truth, the nickel glow remains. By late February, a faint rhythmic modulation appeared in the emission lines, oscillations every 7.2 hours, matching the comet's rotation period. That modulation meant the nickel-rich regions were localized, not evenly spread. Something on its surface, or within it, was breathing, periodically exposing a reflective region to the sun. Imagine a vast, silent machine turning in darkness, flashing metal at each rotation, whispering its presence across millions of kilometers through the faintest variations in light. One of the observers at KEK, half-joking, called it the beating heart of Atlas. But jokes carry unease. If 3I Atlas is indeed more than a comet, its timing is uncanny. It arrives during one of the most turbulent solar cycles in decades, when Earth's magnetic field is weakening, when satellite systems are vulnerable, when humankind's eyes are everywhere but inward. Some wonder if it came by chance. Others suspect purpose. Is the object here to observe, or to awaken something dormant in the sun itself? After all, the triple eruption coincided with its arrival. The chemistry and the light may not be separate mysteries, but facets of the same orchestration. What if the sun's reaction was not random? What if the chemical signature and the solar flare were cause and effect? A test, a handshake, a signal exchange between star and visitor? The thought is unsettling. Yet, in science, discomfort is often the first sign of discovery. For now, 3I Atlas remains silent, or perhaps speaking in a frequency we don't yet understand. The nickel glow fades as it drifts farther from observation range, leaving behind questions heavier than its mass. If nature made it, we must rewrite our textbooks. If something else did, we must rewrite our place in the universe. And as the data fade into archives, one truth remains luminous in the dark. Light does not lie, but it also does not explain. It shows us the shadow, but not the hand that cast it. If chemistry is the fingerprint of an object, then shape is its soul. It reveals how that object was born, by chaos or by choice. Nature sculpts in randomness, intelligence, sculpts in intention, and when astronomers finally resolved the nucleus of 3I Atlas, what they saw leaned disturbingly toward the latter. The Gemini North Observatory in Hawaii captured the highest resolution imagery to date. Faint, grainy frames sharpened through adaptive optics. At first glance, the comet's nucleus appeared unremarkable, elongated, roughly 350 meters across, surrounded by a diffuse coma. But as the images were deconvolved and filtered, something extraordinary emerged. The nucleus was too cleanly shaped, not spherical like most comets, not lumpy or potato-like 67P Churyumov-Gerasimenko or Halley's Comet. Instead, 3I Atlas showed the outline of a stingray, a broad central body tapering into two symmetrical wings. Along one edge, a faint ridge curved upward, forming what some described as step-like terraces, reminiscent of a pyramid or ziggurat viewed from orbit. Astronomer Dr. Elena Mirov from the European Southern Observatory refused to use those words in her initial report. She preferred geometrically anomalous protrusions, but even she admitted privately that the term didn't do justice to what the images implied. Natural accretion doesn't produce right angles, she told a colleague. If these edges are real, not artifacts, then something has shaped this nucleus in a way we've never seen. Skeptics, of course, mobilized quickly. They argued that the images could be distorted by pixelation, phase interference, or light scattering from the coma, a halo of gas that can mimic structure where none exists. But multiple observatories, using different wavelengths and instruments, repeated the same pattern. Even more unnerving, the shape seemed to persist despite changes in viewing angle. That consistency rules out most optical illusions. If you change your position and the pattern remains the same, then the pattern is part of the object. The stingray geometry, as it came to be called in research circles, soon found an eerie parallel. In 1976, when NASA's Viking orbiter photographed the face on Mars, the world divided into believers and skeptics overnight. Later, higher resolution images revealed a mesa, not a monument. The face vanished under better data, but 3I Atlas defied that precedent. The better the images became, the clearer the geometry grew. Theories branched into two camps. Camp 1 claimed that the shape was purely mechanical, formed through rotational shedding and jet erosion. In this view, the comet's spin caused volatile jets to blast material away in repeating patterns, carving symmetrical lobes like a potter's wheel spinning wet clay. Camp 2 whispered a different possibility, that the geometry was architectural, that it might be the residue of construction, perhaps a shell, a casing, a housing for something else. To imagine such a thing feels arrogant, like trespassing into mythology. And yet, nature rarely favors precision, angles, ridges, terraces. These are signatures of will. Dr. Mirov presented the data at a private symposium in Geneva. Her closing slide was simple, a grayscale image of 3I Atlas with the caption, "We are not prepared for the geometry of this universe." In the audience that day was Dr. Daniel Eklund, a mathematician from Uppsala specializing in form and function in chaotic systems. After the presentation, he made a remark that still circulates among astronomers. When geometry emerges from chaos, it either means you've found a law of physics you don't yet understand, or a blueprint. The next weeks brought a quiet kind of hysteria. Social media turned the stingray shape into viral art. Conspiracy channels called it an alien craft. Skeptics mocked both sides. Meanwhile, the professionals did what they always do when the unknown knocks. They compartmentalized. NASA classified several internal memos regarding the Gemini and VLT datasets. The official explanation was image calibration under review, but leaks soon confirmed that data beyond a certain resolution had been restricted to military access networks. When journalists asked why, the response was bureaucratic poetry. Out of an abundance of caution, pending verification of signal artifacts. Caution, of course, is another word for fear. The silence wasn't new. In the 1940s and 1950s, governments worldwide had done the same with unidentified aerial phenomena. They called it prudence then. Prudence often means protecting order, not truth. But geometry doesn't bend to politics. Shapes exist whether we name them or not. By early March, a series of light curve studies confirmed what the shape hinted at: periodic reflectivity peaks repeating every 719 hours, synchronized with the object's rotation. That rhythm could be explained by surface variation, or by something even stranger: reflective panels or facets turning toward the sun at fixed intervals. Imagine solar panels slowly sweeping through space, glinting with mathematical precision. One engineer from JAXA, who had worked on spacecraft heat shielding, anonymously commented in an online forum, "If you designed a probe to survive centuries between stars, you'd make it broad and flat to distribute solar stress. The stingray shape is actually ideal for that." His comment was deleted within hours. In the absence of certainty, imagination becomes the scaffolding of reason, and in those days, imagination was everywhere. Philosophers compared Three-Eye Atlas to Plato's concept of the demiurge, a craftsman shaping chaos into cosmos. Artists rendered it as an ancient emissary gliding silently through time, but among scientists, one thought persisted like static beneath the noise. What if the shape is not the object? What if it is a shell, a vehicle carrying something smaller, denser inside? Something dormant, something waiting. This speculation found fuel in radar data from the Deep Space Network, which hinted at internal density variations. The nucleus didn't behave as a uniform solid. Certain regions reflected signals differently, as if hollow. If confirmed, it would make Three-Eye Atlas the first known partially hollow interstellar object, an engineering hallmark, not a natural one, but confirmation never came. The files were quietly archived. Somewhere between awe and denial, human curiosity hesitates. We are a species that builds telescopes to see infinity, yet trembles when infinity looks back. In the end, only a handful of astronomers continued to track Three-Eye Atlas's changing form. One of them, the Brazilian observer Tiago, the man who first recorded the triple solar eruption, uploaded a final frame comparison before his account went silent. The first image showed a blurred nucleus. The second, taken weeks later, showed faint symmetry sharpening at its edges, almost as if erosion was revealing structure rather than destroying it. Thiago captioned it simply, "It's not falling apart. It's unfolding." Maybe he was right, maybe not, but somewhere between pixel and truth, between shape and meaning, the stingray silhouette drifts onward, indifferent to our disbelief, ancient beyond measure, geometry incarnate. In mathematics, form follows function, but in the cosmos, perhaps form follows purpose. Whatever Three-Eye Atlas is, it was built, by nature or by something that learned from her, to endure. And endurance, Dylan, is the oldest sign of intelligence we know. Space is rarely symmetrical, its debris drifts without choreography, its asteroids wander like sleepwalkers across eons of silence. But three objects moving in unison, each equidistant, each responding to the same invisible rhythm, are not something the universe does by accident. These are the companions of Three-Eye Atlas, the same trio Tiago first captured behind the sun on that October afternoon, when each crossing was followed by a solar detonation. At first, they seemed like ghosts, artifacts, reflections, tricks of instrumentation, but repetition stripped those excuses away. The geometry remained: three shadows, three bursts, three echoes in the heart of our star. In the months that followed, observatories tried to trace their motion relative to the primary object. By analyzing the timing of the flares, researchers estimated that the companions traveled in formation, maintaining a separation of roughly 12,000 kilometers from one another. a pattern too rigid for tumbling debris. If they were fragments, they should drift, spreading apart under the sun's gravitational tides. Instead, their spacing held constant across multiple orbits of observation. The mathematics of their path suggested something astonishing. Each companion moved as if under guidance. They didn't merely follow 3i Atlas, they escorted it. In March, the Solar and Heliospheric Observatory, SOHO, caught a second glimpse during a period of heightened solar activity. The same trio appeared in coronagraph data, faint against the solar glare. Analysts compared their trajectories and found a precise angular offset, as if they were forming a triangle around an invisible center. To anyone who works in orbital mechanics, triangles are a signature. They imply coordination, each vertex maintaining constant distance from the others through deliberate adjustment. It's the very geometry humanity uses for autonomous satellite constellations, like GPS, Starlink, and planetary defense arrays, and here, beyond the sun, nature seemed to be playing the same game, but the implications were heavier than mathematics. If these companions were real, and if their synchronization was deliberate, then 3i Atlas was not alone. It was accompanied. The first theory to gain traction was benign. The companions were gravitationally trapped fragments, torn loose from the main body during a distant encounter. Over time, their orbital velocities aligned through mutual gravitation, forming what astrophysicists call a resonant cluster. The math almost fit. Almost. But when the simulations were run, the resonance fell apart within weeks. The companions should have drifted, yet they hadn't. They were maintaining stability across months. That meant active correction. Something, internal propulsion, electromagnetic tethering, or an unknown stabilizing mechanism, it was keeping them in place. And then came the deeper mystery, their interaction with the sun. Each time one of the companions crossed a particular latitude near the solar equator, the sun erupted 3 times 3 separate events, each aligned to within minutes of the object's trajectories. Solar physicists are cautious people. They know the sun's temper, its cycles, its bursts of fury. But even the most skeptical among them struggled with coincidence of this magnitude. The solar trigger hypothesis emerged quietly. The idea that these objects, whatever they were, might have induced the eruptions. The mechanism,
unknown. The evidence?
uncomfortably consistent. Some proposed a form of electromagnetic resonance, that the companions carried strong magnetic fields which, when moving through the sun's magnetosphere, disrupted its equilibrium, catalyzing reconnection events. Others imagined charged plasma shells acting like catalysts in a cosmic experiment. But a few, more daring voices whispered something else entirely. What if the eruptions weren't accidents? What if they were tests? An experiment conducted not by humans, but by whatever sent, or became, 3i Atlas. A way of measuring the sun's behavior, its energy thresholds, its reactions, because if you wanted to understand a star, if you wanted to harness or even communicate with one, you'd start by provoking it. It's a radical thought, but not without precedent. When humans fire radio pulses at asteroids or detonate charges on comets, we do so to learn their composition, to watch how they respond. What if someone else,
Unimaginably older, does the same to stars?
A whisper among theoretical astrophysicists began to circulate that the companions might not be fragments or escorts, but instruments, sensors, probes designed to induce and record stellar reactions. A kind of cosmic spectroscopy, performed not with light, but with energy itself. Each solar flare then becomes a data point. Each eruption, a reply, skeptics countered swiftly. They reminded everyone that correlation is not causation, that extraordinary claims demand extraordinary evidence. They pointed out that the sun's behavior can fluctuate spontaneously, that the probability, while low, was not zero. But even they conceded one unsettling fact. The companions moved as if they knew. Their timing, their pattern, their unwavering distances. It was a dance choreographed in silence and silence. Dylan is sometimes the truest measure of control. Meanwhile, independent observers kept watching. From amateur networks in Argentina, Poland, Japan, reports flooded in of transient glints near the sun, all within the same window of movement. Some even captured spectral flashes, microbursts of radiation that didn't match solar wavelengths, as if the objects were emitting brief pulses of their own. When those readings were plotted, a faint rhythm emerged. 3 pulses, pause, 3 pulses again. It might mean nothing. Or it might mean everything. As the evidence grew, so did the unease within institutions. No one wanted to be the first to suggest intelligence. History remembers those who do, and usually mocks them. And so once again, silence descended. SOHO's feed continued without commentary. NASA's press releases focused on benign sunspots. ESA quietly redacted the words "unidentified object" from internal summaries, replacing them with "instrumental event." Even the language was retreating, because naming something is admitting it exists. But beyond the boundaries of official silence, the story had already escaped. The world's telescopes could no
longer unsee what had been captured, and if the companions
were truly controlled, whether by an ancient
mechanism or by laws of physics we haven't
yet met, their purpose becomes the question that haunts the night sky. Are they guardians, flanking the main body to protect it as it crosses the inner system? Are they stabilizers, maintaining trajectory through gravitational or electromagnetic balance? Or are they something more menacing? Sentinels, perhaps, performing the same role humanity assigns to warships escorting a carrier? We don't know, but their behavior has earned them new names among those who still dare to speculate. The Triad of Atlas. Thiago, the first to witness them, once wrote in his private notes before disappearing from online forums. If they are companions, they're not following Atlas. Atlas is following them. It was a cryptic statement, but one that many could not shake. Perhaps the comet is not the traveler. Perhaps it is the cargo, and those 3 dark shapes are the hands that carry it. Whatever they are, they move still, silent, precise,
unwavering through the inner system. Their formation holds. The sun remains restless. We've always believed our star was the center of the story. But maybe for the first time,
it's merely the stage, because somewhere out there beyond the glare, 3 unknown companions glide through the light. And their choreography feels less like an accident and more like a message. Every few years, a green star blooms in the night sky. It glows softly against the black. A comet, alive with carbon gas, painting emerald trails as sunlight tears molecules apart. To most, it's a spectacle. To astronomers, it's chemistry. But since 3I Atlas appeared, that color, is that same impossible shade of green, has begun to feel like something else. A signature. In the months after 3I Atlas's first recorded eruptions, other green comets arrived one by one, as if summoned from the edge of the solar system. They bore bureaucratic names. C 2025 A6, Lemon, C2025R2, Swan, and C2025 K1 Atlas. But behind those sterile designations lay a strange coherence. They were all visible to the naked eye. They all burned with the same distinctive cyan glow from diatomic carbon, C2, and all followed unusual, steeply inclined paths that crossed the plane of the ecliptic near the same solar longitude. Coincidence, perhaps, but coincidence was beginning to feel like the universe's most overused disguise. Each of these comets showed subtle irregularities. Lemon's brightness curve fluctuated wildly, as if pulsing. Swan's tail didn't align with the expected direction of the solar wind, bending several degrees off model predictions. And Atlas K1, the most distant, briefly flashed in radio frequencies near 1420 MHz, the same band used in SETI observations. To an untrained observer, these were quirks. To a scientist, they were patterns. Astrophysicist Dr. Valeria Koenig from the Max Planck Institute was among the first to note the timing. She published a quiet preprint titled Synchronous Cometary Arrivals in the Inner Solar System, Statistical Review 2024-2025. Her conclusion was cautious but unmistakable. The clustering of cometary approaches with shared spectral properties and anomalous emission behaviors is inconsistent with random distribution at 98.7%.
Confidence. In other words, something about these arrivals
should not be happening by chance, and yet the institutions stayed silent. Normally, a rare parade of visible comets would dominate the headlines. It didn't. There were no press briefings, no poetic headlines about celestial visitors, mainstream. Coverage remained minimal, but almost willfully so. It was as if the sky itself had been muted. The few researchers who spoke publicly found their data met with unusual resistance when the Koenig requested supplementary observation time from the European Southern Observatory. Her proposal was denied. When a Japanese team attempted to compare the spectral fingerprints of Lemon and 3I Atlas, their telescope queue was quietly cancelled, officially due to maintenance. Science thrives on curiosity, but curiosity has borders, and some borders are enforced. Among amateur astronomers, however, the silence only sharpened attention. In Chile, Night Monkey, one of the independent observers who had verified Tiago's footage, began to record faint emissions from Swan using a backyard spectrometer. He detected a nickel spike eerily similar to 3I Atlas's. Faint, but there. Different instrument, different sky, same anomaly. If true, that meant the nickel imbalance wasn't unique. It was spreading. Online forums buzzed with speculation. What if these comets weren't random fragments from deep space, but part of a coordinated fleet, each following its own trajectory, each glowing green not because of ordinary carbon, but because something was inside, mimicking that color, masking itself in the chemistry of nature? It sounded absurd. But the numbers lined up. Theorists began to revisit an idea long buried in academic archives. The Bracewell probe, a concept proposed in the 1960s by radio engineer Ronald Bracewell. He had suggested that advanced civilizations would not rely on fragile radio signals, but would send autonomous emissaries, self-replicating observers that wander from system to system, transmitting knowledge through proximity rather than conversation. If those probes wanted to remain unseen, they might camouflage themselves as comets, and if they wanted to observe a young civilization star, they might arrive in clusters, timing their approach with solar activity, the same solar activity that 3I Atlas seemed to provoke. The Bracewell hypothesis was dismissed for decades as theoretical indulgence, but suddenly its language was back, whispered in observatories and encrypted research servers. Koenig herself hinted at it in an interview that was never officially published. When natural objects arrive together, displaying spectral coherence and synchronized behavior, we must at least ask if we're looking at a coordinated system, not a random one. The transcript was leaked weeks later. She has not spoken publicly since. Even the James Webb Space Telescope, capable of resolving the infrared composition of these bodies, offered no clarification. When journalists asked NASA whether JWST had observed any of the green comets, the agency confirmed that data existed, but said it was pending peer review. No images were released. No spectra published. Peer review, in this case, had become a locked door. Meanwhile, in the absence of official voices,
a strange pattern began to
unfold across smaller observatories whenever one of these comets approached perihelion, its closest, passed to the Sun, solar flares intensified. The pattern was identical to 3I Atlas's event, though weaker. If plotted on a timeline, each flare's timing matched a corresponding comet's crossing almost exactly. This was no longer coincidence, it was a conversation. And yet, the deeper the pattern became, the quieter the institutions grew. This is how suppression works in science. Not through censorship, but through omission. No one forbids inquiry. They simply fail to fund it. The world looks elsewhere. The data fades. The pattern dissolves into coincidence once more. But Dylan, silence itself can be data. When multiple green comets appear, each defying physics in subtle ways, and every major observatory looks away, that silence becomes signal. It tells us that something in the data terrifies those who understand its implications, because if multiple comets share these properties, unusual polarization, nickel-rich composition, geometric symmetry, then we're no longer talking about one mystery. We're talking about a network, a pattern, not across years, but across space, a constellation of behavior that stretches from the outer solar system into our very skies. And if there is a pattern, there is intention. Somewhere in the archived data of SOHO and the spectrograms of KEK Observatory, that intention is hidden in plain sight. The ratios, the timing, the light, all whispering the same question. What if they are not visitors, but messengers of something larger? What if 3I Atlas was only the first we noticed, the one bright enough, bold enough, or perhaps deliberate enough to make us look? And what if the others, Lemon, Swan, Atlas K1, are already here, orbiting in silence, watching? The night sky still glows faintly green in long exposures. Most call it coincidence, others call it a warning, but those who've seen the data know silence can be the loudest sound in the universe, because sometimes the question isn't what are they saying, it's why have they all gone quiet at once? The sun has always been our constant, burning, unyielding, beyond control. Every culture on Earth built its first gods in its image. To imagine that anything could influence it, let alone trigger it, feels like blasphemy against physics itself. And yet, the numbers refuse to stay silent. When 3I Atlas and its companions crossed the solar equator, 3 coronal mass ejections followed within hours. Each eruption released billions of tons of plasma, accelerating at millions of kilometers per hour. Each originated from magnetic regions that, according to the Solar Dynamics Observatory, had been stable for weeks. Nothing about them was predictable. To solar physicists, the timing was the wound that wouldn't close. Coincidence? Possibly. But 3 consecutive coincidences aligned to moving coordinates bordered on defiance. So began what came to be whispered as the solar trigger hypothesis. a phrase that even now most scientists refuse to say on record. The hypothesis proposes a simple, terrifying idea that 3I Atlas and its three companions didn't merely pass by the Sun, they interacted with it, not gravitationally, electromagnetically. Every object in space carries charge. Even a pebble has an electric personality built from the electrons that coat its surface. When a charged body moves through a magnetic field, especially one as volatile as the Sun's, it disturbs it, twisting invisible threads of energy. Usually these disturbances are small, harmless ripples, but what if the objects were not neutral? What if they were designed to be catalysts? Dr. Eiji Nakamura, a Japanese plasma physicist known for his work on magnetic reconnection, described it best. The Sun's magnetic field is a coiled spring. It stores immense energy and tension. A small, well-timed disturbance could snap that spring, releasing energy far beyond the trigger's size. In plain terms, the Sun doesn't need to be forced to erupt. It only needs a nudge. If those three companions carried even weak magnetic fields, or emitted charged plasma as they passed, they could, theoretically, provide that nudge. They wouldn't need to be massive. They'd only need to know when and where to touch, skeptics
argue the Sun is far too vast to be influenced
by anything smaller than a planet. But the counter-argument is subtle. Influence doesn't scale with size, it scales with precision. Violin string needs only a feather's weight to sing if you touch it in the right place. The Sun is a symphony of fields and flows. One nudge in the right measure, and the whole orchestra roars, and the timing of those eruptions was perfect. To test the theory, researchers modeled the Sun's magnetic topology during October 2025. They found that 3I Atlas's trajectory intersected one of the largest active filament loops on record, a region where magnetic tension had been building silently for weeks. If an object with even a micro-Tesla of magnetic field strength passed through, it could have triggered reconnection. The solar equivalent of a heartbeat skipped. Each flare that followed would then be the Sun's pulse, catching up. And the companions? They could have been synchronized triggers, timed to test different latitudes, or to amplify one another. At first, this idea circulated as fringe speculation. Then came the January 2025 triple flare, forecasted as cannibal CMEs by NOAA. 3 eruptions merging into a single massive wave. Their source, the same longitude where 3I Atlas had crossed months earlier. The pattern was repeating. The Sun was reacting to something. By now, even cautious researchers began to whisper that we might be witnessing a controlled experiment on a stellar scale. Who, or what could perform such an experiment, is a separate
question, but the data itself is
indifferent to belief. If these events were natural, the probabilities were infinitesimal. If they were deliberate, they were elegant. The term deliberate carries weight. It implies intelligence, motive, curiosity, but it also implies risk, because if the Sun can be triggered, and even fractionally, well, it means the star we depend on for every heartbeat of life can also be influenced. And if someone else can influence it, they can communicate through it. Imagine the Sun as a galactic telegraph, its eruptions as pulses of information, magnetic Morse code across the heliosphere. To a civilization advanced enough, solar physics could be a medium of language, each flare a syllable, each eruption a word. When scientists plot the timing of those 3 flares, their intervals form a simple mathematical sequence, roughly 1.23 in duration spacing. A coincidence, perhaps, or an introduction? The mainstream view remains cautious. Dr. Marcos Alvarez from the Solar Physics Division at ESA summarized the tension succinctly. Our job is to describe, not imagine. But sometimes the data seems to be doing both. Privately, several of his colleagues admitted that the correlation between the object's paths and flare timings remains statistically inexplicable. One researcher reportedly said off record,
"It's as if the sun knew they were coming, but..."
Perhaps that's the wrong framing. Perhaps it wasn't the sun that reacted, but 3I Atlas and its companions that responded. Imagine. A network of devices built to study stars, moving silently from system to system, using each host star as both power source and transmitter. They wouldn't send radio signals. They would use light and magnetism themselves, readable only to those who understand stellar language. It's a theory that stretches the boundary between science and metaphysics, yet it fits the data uncomfortably well. The sun flared not once, but 3 times. Each event corresponded to an object, crossing its magnetic threshold. Each flare released more energy than all of human civilization has produced in its entire history, and somewhere within those storms, information may have been exchanged. The implications are staggering. If the solar trigger hypothesis holds, then we are not merely observing cosmic debris, we are witnessing a dialogue between intelligence and a star, not a broadcast, not a message to us, but something more fundamental. A handshake between creation and comprehension, a test, perhaps, or a reminder. For now, the official reports remain diplomatic. NASA's public statement reads, "No evidence currently supports external influence on solar dynamics." And yet, the same report quietly notes anomalous temporal correlations, the bureaucratic equivalent of a confession whispered behind data. Out beyond the noise, 3I Atlas continues its journey. Its companions maintain formation, silent as punctuation marks in a sentence we haven't learned to read. The sun, meanwhile, grows restless again. Its surface crackles with new magnetic loops. Another cycle begins. Perhaps it's coincidence, perhaps cause. But as the light reaches us 8 minutes later, washing our planet in warmth and radiation, one can't help but wonder, maybe the sun isn't just shining. Maybe it's answering. Science is often imagined as a fearless pursuit, a cathedral of reason where truth stands above ego, politics, or fear. But in reality, science is human, and humans guard their gods, even when those gods are made of data. When the anomalies around 3I Atlas began to stack, the synchronized eruptions, the metallic chemistry, the stingray geometry, the companions moving in perfect unison, the reaction inside the world's scientific institutions was not revelation. It was retreat. Behind closed doors, silence is a form of protection, not of the public, but of the paradigm. Paradigms are delicate. They define careers, research funding, reputations, entire lifetimes of belief. Admitting that something as small as a comet could destabilize those foundations is unthinkable for many, not because it's impossible, but because it's inconvenient. If 3I Atlas is natural, science is safe. If it is not, then everything we know about planetary formation, interstellar travel, and cosmic history must be rewritten. So the walls went up. It started quietly. In early 2025, several observatories that had been releasing raw datasets on solar interactions abruptly restricted access. SOHO's Open Data Portal, a public archive for decades, suddenly delayed uploads by 72 hours, citing server maintenance. ESA's Solar Orbiter team began redacting event timestamps. Requests for raw telemetry from Japan's Hinode mission went unanswered. Officially, it was routine. Unofficially, it was containment. The pattern extended beyond astronomy. In Geneva, a physicist at CERN reportedly attempted to cross-correlate neutrino readings from the Ice Cube Observatory in Antarctica with the timing of the Three-Eye Atlas. Flares his findings tiny, bursts of high-energy particles emerging upward through the Earth, hinted at correlations that defied logic. When he submitted the paper for preprint, it was withdrawn within hours. The reason? Pending further review. But in modern science, further review is often where new ideas go to die. You see, Dylan, knowledge isn't only discovered, it's approved, and approval requires gatekeepers. The gatekeepers are not villains. They are cautious custodians. They live in a world where a single error can destroy credibility. But sometimes, caution becomes the enemy of truth. History is full of examples. Galileo's moons of Jupiter dismissed as optical illusions, Wegener's continental drift, ridiculed for decades, the first evidence of
exoplanets ignored because no one
believed stars could have worlds. And now, perhaps, Three-Eye Atlas, a dataset too dangerous to publish, too precise to deny. Inside the space agencies, the fear is not aliens. It's uncertainty. Uncertainty erodes control. It complicates politics, threatens public confidence, and invites speculation that no press office can manage. So, as one NASA administrator reportedly said off record, until we can explain it, we'll say nothing, because anything we say will be taken as confirmation. In that sentence lies the quiet confession of an empire built on information. Silence is safer than truth. Funding boards responded in kind. Proposals mentioning Three-Eye Atlas or its companions were systematically declined. Peer reviewers flagged them as insufficiently constrained, non-standard, or outside mission scope. It wasn't censorship. It was filtering. A system built to eliminate noise had begun. Eliminating novelty. One researcher at the University of Cambridge compared it to immune response. Academia has antibodies. When data threatens the organism attacks the data. And those antibodies were now everywhere. Meanwhile, in classified networks, where civilian telescopes cannot look, the story was very different. Signals from NASA's Deep Space Network, cross-referenced with ESA's Bepi-Colombo, reportedly detected faint radar echoes near the path of Three-Eye Atlas's companions. The echoes were consistent, structured, and short-lived, like reflections from objects with smooth metallic surfaces. If true, this was confirmation, but those files remain sealed. Freedom of information requests filed by journalists were denied under Section 215 of the National Security Act, the FEAT clause used for protection of foreign or extraterrestrial technological data. The irony was breathtaking. The clause already assumed the existence of such data. At the same time, whispers grew of a high-level meeting at Quantico, attended by US Space Force analysts and radio telescope operators. Officially, they were reviewing solar interference on satellite communications. Unofficially, it was a briefing on the Atlas event. The attendees were instructed not to take notes. Afterward, one participant leaked a single line of dialogue that has since become legend among researchers. We're not asking what it is, we're asking if it's alone, and yet, for all the silence, fragments of truth still escaped. Buried in the language of bureaucrats who must publish something. No AA's March solar report mentioned unexpected magnetic harmonics, coinciding with external transients. ESA's observational bulletin cited objects of undefined luminosity near the heliospheric equator. Each phrase was a breadcrumb, the kind scientists leave when they can't say what they really know. The philosophical tension runs Deeper, science is built on two fears: the fear of being wrong and the fear of being first. The first fear kills
boldness. The second kills
discovery. When Dr. Sabine Hossenfelder warned that refusing to investigate potential artificial origins would be our civilization's greatest error, many dismissed her words as melodrama. But history tends to side with those who ask the questions.
everyone else avoids because knowledge doesn't
Just expand, it demands courage. Still, there are those who continue to watch, quietly, obsessively. Independent observatories, amateur radio astronomers, and retired scientists who have nothing left to lose. They share encrypted data, comparing pulse timings from solar flares to frequency shifts in Earth's magnetic field. Every few weeks, they find new patterns, faint but persistent, as if the sun itself is whispering in code. They call themselves the Quiet Network. They operate without institutions, without funding, and perhaps without fear. To them, the silence of agencies isn't an obstacle, it's a challenge. Their motto, borrowed from the earliest age of exploration,
is simple: nullius in verba. Take nobody's word for it. Dylan.
History tells us that civilizations collapse not when they lack knowledge, but when they lack the will to face it. The truth of Three-Eye Atlas, whatever it is, will not stay buried forever. Because truth is not a file that can be redacted. It is light, and light, like the sun it reveals, cannot be hidden indefinitely. One day, perhaps soon, the data will leak, the images, the ratios, the flares that align too perfectly. When that day comes, the world will look up and realize that the silence wasn't ignorance, it was fear, and maybe, just maybe, we'll finally understand that knowledge was never meant to be guarded, only witnessed. There are moments in history when every thread, scientific, human, and cosmic, begins to pull toward a single point. A moment when data stops behaving like numbers and starts feeling like destiny. For those who have followed the trail of Three-Eye Atlas, that moment is now. For nearly a year, the anomalies have multiplied. 3 companion objects moving in formation. The sun erupting in answer, a comet made of metals that should not coexist, a geometry that refuses to erode, and a growing chorus of other green comets appearing as if called by the same unseen hand. Each event alone could be dismissed. Together, they form a symmetry too elegant to ignore. It is as if someone, or something, is weaving these coincidences into a pattern visible only when seen from far enough away. From Earth, we see it as mystery. From a greater distance, it might look like design. Astronomer Dr. Valeria Koenig, before vanishing from public view, wrote a final note in her lab book: when patterns begin repeating across scales, in chemistry,
magnetism, geometry, and light, they cease to be coincidences.
They become syntax. Syntax, the grammar of the universe, the possibility that everything we have recorded, the nickel ratios, the magnetic flares, the synchronized arrivals, is not chaos, but language. If so, what is it saying? Perhaps Three-Eye Atlas is not a visitor, but a message, a cosmic artifact scripted in matter and motion, carrying instructions or memory from a time before our sun was born. Every anomaly, from the impossible polarization to the stingray shape, could be part of that message's architecture, encoded in ways we don't yet understand. To those who fear imagination, that sounds like poetry. But to those who understand the precision of nature, it sounds like engineering. The James Webb Space Telescope, still silent on its findings, is rumored to have observed 3I Atlas during its perihelion. Inside NASA, those images are said to show faint infrared lattice patterns across the comet's surface. Grid lines, too, even to be fractures, too consistent to be natural dust flows. If true, they could be the first visible evidence of structured matter. A manufactured surface, camouflaged beneath centuries of interstellar dust. It would be proof not only of intelligence, but of patience. Something built to travel longer than civilizations live, perhaps even longer than stars burn. The implications fracture the human imagination. If we are being observed, it may have nothing to do with us personally. Perhaps we are simply along the way. Another stop on a grand survey that has spanned millions of systems, each one recorded and moved past. Maybe they have no interest in conquest or contact. Maybe they are archivists, preserving the cosmos before entropy erases it. Or perhaps they are seeds, dormant technologies scattered through the galaxy, waiting for the right conditions to awaken, and the right condition might be the touch of a star. That idea that a star's magnetic field could awaken something hidden within a comet has taken hold even among cautious physicists. They call it the stellar ignition hypothesis, that interstellar probes or ancient self-sustaining devices could remain inert until bathed in the energy of a new host star. If true, then 3I Atlas's approach to the Sun was never
random. It was ritual. A return to the light that would wake it, and
the triple solar eruption was not the beginning of the story. It was the response, the Sun answering in kind, like a heartbeat recognizing its pulse. Of course, none of this is proven. We still lack the data, the access, the courage. But perhaps proof is not the point. Because even if every anomaly finds a natural explanation, even if 3I Atlas turns out to be nothing more than a beautiful coincidence written in dust and light, the questions it forced us to ask will remain. They
are not about aliens, they are about us. Why?
Did we assume we were alone? Why did we fear what we couldn't explain? Why did our institutions choose silence over wonder? The greater revelation of 3I Atlas may not be that we are being watched, but that we have forgotten how to see. When the great physicist Carl Sagan wrote that we are a way for the cosmos to know itself, he could not have imagined how
literal that might one day become, perhaps.
Comets like 3I Atlas are the same, mechanisms by which the universe remembers its own birth, carriers, a pattern of memory, of code. If intelligence exists out there, and the evidence now whispers that it might, then maybe it has always existed everywhere, in every law of nature, in every equation that balances too perfectly to be random. Maybe the line between life and physics isn't a line at all. Maybe the universe itself is alive, and what we call alien is merely a fragment of its consciousness moving through time. The data suggests that 3I Atlas is leaving now, drifting back toward interstellar space, its companions still in formation, their geometry unchanged, but what it leaves behind is heavier than gravity. It leaves questions that no telescope can answer. It leaves the ache of
recognition, meaning that haunting suspicion
that we are part of something vast, symmetrical, and ancient beyond words. In a way, that is what science has always sought, not certainty, but belonging, to look into the dark and find a reflection staring back. Perhaps someday, centuries from now, another civilization will find our own probes drifting between stars. Voyager, pioneer new horizons, and wonder if they too were built by something long vanished. Perhaps they'll decode the plaques we sent, the radio songs, the coordinates of our tiny blue world, and perhaps they'll ask the same question we ask now. Were they trying to speak, or simply to be remembered? Because memory, Dylan, is a form of immortality, and maybe that's all any intelligence ever truly seeks. Not conquest, not dominion, but remembrance. So if 3i Atlas is indeed a message, perhaps it's not meant to terrify us, but to remind us that the universe is listening, and has been all along. We are not the first to wonder where we came from. We will not be the last to look up and feel small, but for a brief,
brilliant moment, a comet from another star crossed our sky and made the sun sing. And that song,
whether born of nature or of design, belongs to us now. A note in the cosmic symphony of discovery. Maybe the truth is simple. Maybe the universe isn't silent at.
Or maybe we just weren't ready
to hear the language it's been speaking for billions of years. Because sometimes the most profound messages aren't sent through words or signals. They're written in light, in geometry, in a comet's impossible path across the face of a waking sun.